We've seen that R2 is a vector space consisting of pairs of real numbers v1, v2. Okay, let me write that here. R2, and it consists of pairs v1, v2. Okay, and v1 and v2 are real numbers. We can interpret the vector v1, v2 as an arrow in the plane having a certain length and direction. Okay, so let me draw that here. Okay, starting from the origin, we have this vector. Okay, now the length of the vector v can be found using the distance formula for 2 points, u1, u2, and v1, v2. Here's the distance formula. u1 minus v1 squared plus u2 minus v2 squared and the square root of that whole thing. Okay, this is the distance formula for 2 points. Okay, now the length of v, okay, that's the distance between the origin, which is at 0, 0, and the point v1, v2. Okay, so the distance, that's the square root of 0 minus v1, that squared, plus 0 minus v2 squared. Okay, and the square root of that whole thing. Okay. Now, if I simplify this a little bit, I get v1 squared plus v2 squared. Okay, the square root of that whole thing. Alright, now the length of a vector v, say v1, v2, dot dot dot, vn in Rn. Okay, that's defined analogously as the square root of v1 squared plus v2 squared plus dot 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 plus vn squared. Okay, so it's pretty much the same thing. That's the distance of this vector. The length of v is denoted like this, with 2 vertical bars. That's the norm of this vector v, and it's called the norm. The norm of v. Okay, let's do an example. Find the norm of this vector. Okay, so if I drew the graph, 1, 2, 3, 1, 2, 3, 4. Okay, those are the coordinates for this vector. Okay. So we want to find the length of this arrow here. The norm of v is the square root of 3 squared plus 4 squared. Okay, so that's square root 9 plus 16, so that's the square root of 25, which is 5. If we multiply a vector v by a scalar c, the length of the vector changes. Okay, if c is positive, then the resulting vector c times v will point in the same direction as v. Okay, now if c is negative, then c times v will point in the opposite direction as v. Okay, so for example, let's say c equals to 2 and v equals to 3, 4. Then we get c times v, and that's 2 times the vector 3, 4. Multiply that out, that's 6, 8. Okay, now if I graph this, I'm gonna get 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that vector right there. Okay, now the length of 2 times 3, 4 is twice as long as the length of just 3, 4. Okay, so it's twice as long as just 3, 4. Okay. Now, if c was 10, the length of 10 times 3, 4, that would be 10 times the length of 3, 4. Okay. Now, remember c equals to 2 for that example. Since 2 is positive, 2 times 3, 4 points in the same direction as 3, 4. Okay, now if c equals to -2, then c times v, that's -2 times 3, 4, which is -6, -8. Okay, and let's graph that here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's this vector here. Okay, the direction of c times v is the opposite of that of just v in this particular case because c is negative. And the length of -2 times 3, 4, that gets scaled, okay, by a factor of the absolute value of -2. Okay, so -2 times the vector 3, 4 is twice as long as the original vector 3, 4. Okay, so you can see what the scalar c does to the vector v. If it's positive, it just points in the same direction, but if it's negative, then it points in the opposite direction and it changes the length, it scales it by the absolute value of that scalar c. Okay. Now, in general, if v is a vector in Rn and c is a scalar, just a real number, then the norm, which is the length of c times v, that's equal to the absolute value of c times the length of v. Okay, so that's that scaling factor right there, the absolute value of the scalar c. Now, if v is a non-zero vector, okay, non-zero vector, that just means it's not the zero vector. Okay, in Rn, and we want it to find the vector pointing in the same direction as v, but having a length of 1, we would have to scale the vector v by dividing by the norm of v. Okay, so we can form this vector u by taking 1 over the norm of v and multiplying by v. Okay, so this is called the unit vector. Unit vector in the direction of v. Okay, and as you can see, it's just the vector v scaled by the norm of v. Okay, let's do an example. Find the unit vector in the direction of the vector 3, 4. Okay, so let's find u. That's 1 over the norm of v times v. Okay, we found the norm earlier, which was 5, so take 1 over 5 times the vector v. Multiply that out. So we get this vector. Okay, and if you were to graph this, so here's the original vector, 3, 4. And if you were to plot this unit vector u, it would be somewhere here. Okay, so it's just the same vector, it's pointing in the same direction, but it has length 1. Okay, so it's shorter right here.